All right, let's pull back the curtain on a hidden world, an invisible battle of chemical opposites that's being fought all the time, in your kitchen, in your bathroom, and yet even inside your own body.
I mean, think about it for a second. You know that sharp, kind of puckering feeling you get when you bite into a lemon? That's not just a flavor, that's chemistry in action.
And then, on the flip side, what about that slick, almost greasy feeling you get from soap when you're washing your hands? Well, that's the other half of the puzzle. These two totally different feelings are clues, and they point directly to our two main characters.
And here they are, acids and alkalis. These are two really important families of chemicals, and as we're about to see, they are complete and total chemical opposites. So this breaks it down perfectly. Acids, they've got that classic sour taste. Alkalis, they have that soapy, slippery feel. But look at that middle ground. Both of them can be corrosive, and that means they can seriously damage other materials. They are definitely powerful forces.
And you know acids way better than you might think. They're in the vinegar for your salad, the citric acid in your orange juice, even the carbonic acid that gives your soda that fizz. And maybe the wildest one? Your own stomach makes a super powerful acid to digest your food.
And alkalis? They're just as common. They're in your toothpaste, the baking powder for cakes, and of course, all your soaps and cleaners. Even that antacid you might take for heartburn, that's a classic alkali. They are literally all around us. Okay, but here's where it gets a little tricky. Even though they have these really different properties, a lot of these things are just clear, colorless liquids. They can look exactly like a glass of plain old water. So, if you can't tell just by looking, how in the world are you supposed to know if you're dealing with a dangerous chemical or just, water? We need a tool. We need a way to reveal their secret identity. And that tool is called an indicator. Think of it like a chemical detective. Indicators are these special substances that change color the second they touch an acid or an alkali. And just like that, the mystery is solved. So the most basic tool here is litmus paper, and the rule is super simple. If you dip blue litmus paper into an acid, it turns bright red. And if you dip red litmus paper into an alkali, it turns deep blue. It's a really simple yes or no test. But just knowing if something is an acid, well, that's only half the story. The next, and maybe more important question is, how strong is it? Because let's be real, there's a huge difference between lemon juice and battery acid. And that right there is the big limitation of our simple litmus test. It'll give you a thumbs up or a thumbs down for acid or alkali, but it can't tell you anything about its power level. For that, we've got to upgrade our toolkit. So let's bring in the more advanced tool, the universal indicator. Now, this isn't a simple yes or no test. It's more like a chemical power meter. It shows you a whole rainbow of colors, and each color matches up with a specific strength. And this whole system is called the pH scale. It runs from 1 to 14. Really low numbers, like pH 1, mean a strong acid. Think stomach acid. A perfect 7 right in the middle is neutral, like pure water. And the really high numbers, like pH 14, mean a strong alkali, like a serious drain cleaner. Everything has its spot on the scale. So, we've got these two powerful opposite forces. What do you think happens when they finally meet? It's not some crazy explosion. It's something way more elegant and way more useful. It's called neutralization. And honestly, it's like a superpower in chemistry. When you mix an acid and an alkali in just the right amounts, they chemically cancel each other out, and you're left with something neutral, usually just salt and water. It's a perfect balancing act. Now, this superpower isn't just for a science lab. You actually use neutralization all the time, probably without even thinking about it, to solve a bunch of everyday problems. Oh man, we have all been there. Your stomach's making too much acid and you get that awful burning feeling. So, what do you reach for? You grab an antacid, right? Well, that's just a mild alkali, and it has one job. Go into your stomach and neutralize that painful extra acid to make you feel better. That's neutralization saving the day. Or how about this one? You're outside and bam, a nasty bee sting. A bee's venom is acidic, and that's what causes that sharp, burning pain. So how do you fight an acid? Well, you fight an acid with its opposite. Putting a simple paste of an alkali, like baking soda and water, on the sting helps neutralize that venom and takes the edge off the pain. That's just basic chemistry as first aid. And here is one you deal with literally every single day. The bacteria in your mouth are constantly making acid, and that acid is the #1 enemy of your teeth. It's what causes cavities.
So what's the fix? Your toothpaste. Most toothpaste is made to be slightly alkaline for this exact reason, to neutralize all those acids and protect your teeth. Every single time you brush, you're performing a neutralization reaction in your own mouth.
So the main point here is this. Acids and alkalis are not just some boring topic in a textbook. They are active, powerful players in your life every single day. And understanding them gives you a kind of toolkit to deal with all sorts of things, from an upset stomach to keeping your teeth healthy.
Once you start looking for it, you'll see this chemical balancing act happening everywhere, which kind of makes you wonder, right? What other invisible battles are shaping the world right under our noses?